Yeah. Yeah.
But then that would you probably memorize it.
Yeah.
Oh yeah, exactly.
I don't know. That's never happened before.
Because today, during the maths exam, I know how to the answer is, but I forgot the formula. I can't write
Did
by
John
step
not
by
let you
step.
use a formula book?
No.
No,
Whoa.
we don't have
Although
formula
we
book.
can't nail
And we forgot
Yeah.
formula.
I would have gone like an historical packet.
Our students always say that, but it's never true. Okay. Right. That. And you know deep down I'm right.
Maybe an 8.
Alright. Alright, so the last topic here is called the pendulum. You can write that down. You okay, Siva? You need to move? You got that? Pendulum. Yeah. Yeah. Some of you know this word. Chow, do you know this word? Yeah. I think you two guys know it. And you would know it, Siva. Kim, do you know this word? Yeah.
It's a noun.
What is it?
It's a noun.
Is a noun correct? That is true. Noun for what though? So pendulum is like this. This is a pendulum. That's a pendulum. This is just a picture of a pendulum with all the parts named. So this part is called the pivot, but you have that word before, pivot. Now, this is a massless rod, meaning we imagine 0 kilograms here, and this is a massive bob, meaning we imagine all the mass is here. Okay. This is the equilibrium position. So this is like the equilibrium is like the center or the rest position. And then this is the amplitude, the biggest situation, the amplitude. And then it'll swing all the way over left and right like this. So this path is called the trajectory. Okay. Yeah, you need the names, so drawing this would be good. Okie dokie. You drew that, Siba? You got all the names too? You got that, Matt? George?
What is Bob's trajectory?
There's the Bob's path.
Oh.
You got this, Andeka? Yeah. Okay. Cho, are you ready? Okay. So, the next part is something for me to write, and I need you to write this down as well, because it's useful for one of the experiments you do next semester. Okay, so what I'm about to write you will need for one of your experiments. Okay, so if you can write this with me. Right, so let me just draw the pendulum here. And it goes back and forth. He's alright, leave him alone. Now, it's going back and forth like this. Okay, so let's say the pendulum has a length L and a mass M. What are the forces on the mass M? Two forces, what are they? The weight, mg, and what is the other force? The tension here. Yeah? Now, I'm going to resolve this mg. So, there's a component this way, and then there's a component this way. Now, let's just call this angle here theta. So, what would this angle be? That would be theta. So, this here would be mg cos theta and mg sine theta. Now, are you happy if I say, oh, and we'll call this t. Well, no, I want to use a different letter because I'm going to use t later. S. So, are you happy if I say S equals mg cos theta? Happy or unhappy with that? Happy. Now, because the reason is, if the S was bigger than the mg cos theta, then the pendulum would be shrinking. And if the mg was bigger than the S, the pendulum would be stretched out. Now, what's so great about mg sine theta? Well, that's not zero. In fact, if you want, I can put a minus in here because it's going to the left. That is equal to some force going to the left. Okay, so far? Yeah. Now, we have to figure out what theta is. So what I'm going to do, you see this distance here? Oh, no, I want a different colour. What colour have I not used now? Have I used all my colours? Right. Go back to purple then. Right, you see this colour here? Not this colour. This line here. I'm going to call this distance, that distance, I'm going to call it x. Now, I'm going to say sine theta is roughly equal to x over L. Now, why am I saying it's roughly equal? Why is it not exactly equal? What's the reason, do you think?
Because it's curved.
Yeah, it's because the part is curved. It should be a triangle, it should be a straight line, okay? But if this x is small, then it's actually not so bad, okay? So, what I can do is I can put that back in here. So I get minus mg x over L equals force to the left. Now, if we think about it, well, actually let me zoom out a little bit. Newton said F equals ma. So now we get ma equals minus mg over Lx. Of course, I can cancel the m's. So I'm left with A equals minus G over Lx. Now this G over L is just a constant, right? Does the G change? No. Does the L change? No. So what I'll do is I'll say call omega root G over L. So then you can write this as minus omega squared x. Now that should look familiar. Where have you seen that formula before? The previous lesson, yeah. This is simple harmonic motion, which is actually not surprising because if you think about it, this is a simple harmonic motion. So we've actually figured out that the omega is the root G over L, because if you make omega equal to root G over L, you get the simple harmonic motion formula here. So therefore, the time, which is 2 pi over omega, means that the time is 2 pi root L over G. That's the formula for the time it takes the pendulum to swing once. Now, what do you notice about this formula? Do you notice that there's no M in it? In fact, what's the only thing in the formula you could change about the pendulum? It's the L, isn't it? What happens if the L is bigger? What happens to the T? Is it bigger or is it smaller? It's bigger. Okay? And if you make the L smaller, you shrink the L, what happens to the T? It's less as well. Okay? I think it was Galileo, who noticed this. You know Galileo? He noticed that if you make the L bigger, you make the time bigger. If you make the L smaller, you make the time smaller. He didn't have a formula like this, but he did notice the relationship between the T and the L. Okay? You need all of this for your lab next semester, so can you carefully copy this proof into your notebook, please? Some of you have seen this formula before or not? No. You've seen it before? You haven't seen it? And what? Have you seen this formula or is it a new formula? New? Yeah. No, don't take a picture. I don't mind waiting for you. You can write it down. Oh, you can zoom in. Yeah. Oops. Do you need to wear glasses? Do you wear glasses?
Yeah.
Do you not want to wear it now?
No, it's kind of heavy, so it falls down. I don't.
Maybe you need contact lenses, you know?
Yeah,
Oh, that's what you're wearing?
Yeah.
Oh, great. The top is being cut off, and so is the bottom. Can you still see if I zoom out a little bit?
Yeah.
That's still okay, isn't it? You can have it all copied. Do you see that? Everything's copied? Oh, wonderful, okay. Were you writing as I was explaining? No? Okay. How come you're so much faster than some of these guys?
So
Yes?
wait, sine theta roughly equal to x over L.
Are you asking me why or why not? Why? Why? What about if I drew this triangle here? And I said this is theta, this is 90, this is L, and this is x. What is sine theta? It's x over L, isn't it? But it's not quite exactly x over L because the x in our picture is a bit curved. So tell me, is sine theta, it's not actually x over L. Is it bigger or smaller than x over L? Oh, you had a 50-50 chance and you went the wrong way. I think it'll be smaller than whatever our x over L is. Yeah. Okay. How are we doing, George and Matt? Not yet? Okay. Yeah. Minus G over L, yeah.
Why is W equal G
Yeah.
over L?
Yeah.
And another one is L over G.
Because the T is 2 pi over over omega, so it's upside down. But anyways, this is my choice. And the reason it's my choice is because I want to make this from this. I want to try and go from here to here. And to do that, I need to make this choice.
Where do you get the choice?
Okay.
If you look at it though, seriously, if you look at it, if you know you're trying to get to this, and you look at what you have, you realize you have the x, you have the minus, so you have to call this guy omega squared. Yeah.
Where omega square is equals this.
Say again?
Yeah.
Yeah, omega squared is this. G over L.
No, the formula is the
This?
omega equal.
Yeah.
I got confused.
Yeah.
Why is G?
Why is this? That's what I was trying to explain to Matt there. This is my choice.
Yeah.
You know, like for example, if I said x plus 1 squared plus x plus 1, shapers, plus 2, you might say make u equal to x plus 1. Have you seen this in maths? No?
Yeah.
Like you know, if I say 2x plus 1 squared plus 2x plus 1 plus 3, you might want to call this guy u, because then you would have u squared plus u plus 3. You've seen this in maths?
Okay.
So, I'm making a choice which is helpful to me. So, I need to choose this. Because if I choose this, I can change this into this.
Okay.
Yeah. Okay? Yeah. Continue? Do you have this, Matt? Okay, so here's a very simple little question for you to do. I have a pendulum which is 1 meter long, and I let it swing 10 times. 10 times. I want to know how long that would take. So you'll need your calculators. 1 meter, swing it 10 times. You okay, Kim? You look very tired again.
No, I'm not serious.
Are you sure? Did you get a full 5 hours of sleep last night, or more or less?
More?
Good.
No.
Yeah, it was not just a proof, because you need it for your lab next semester. Right. What's the L here? 1. And the G? 9.81.
9.81.
So look, this is the time for one swing. 2 seconds. So what do I do next? Multiply by 10? That's the time for 10 swings. 20 seconds. 20.1 seconds. Yeah? It's okay, Ken? Siva?
Yeah.
Yeah. You understand what I did previously, and then I just multiplied this by 10. So.
Why was
Oh, because my question. Read it there.
Oh, okay.
Yeah.
Why is no minus 9.81?
Oh, we keep talking about this. One of you keep asking me about this minus. Could you tell them? What do I usually say about the minus?
Yeah, I know because we need to calculate the time, so it's no minus.
Yeah, no minus. Yeah, no minus. Yeah. Minus would be a problem. Yeah. Okay. Do we have this written down? Yeah, Kim.
So isn't it like T for time?
Say again.
Isn't it T is for time?
Yeah, for just one swing.
But it's asking how long is it?
Ah, and this is an English problem. Stupid English is very bad with stuff like this. In English, how long can also mean how much time, not just you're thinking, yeah. It's a problem. It's a problem with English. There was another problem with English that what's his name, Young Peng was unhappy with, because I had in one question, I said something like, a car travels a distance over 10 seconds. Now what do I mean when I say a car travels over 10 seconds? Yeah, in 10 seconds. But he thought it meant beyond 10 seconds, like after 10 seconds.
Yeah.
Because of over.
Yeah, I think over is after 10 seconds.
Yeah. But in English, if I say over 10 seconds, I mean in 10 seconds. It's terrible. It's really stupid and terrible. So, sorry Kim, yeah, how long here means time.
So how do I know if it's time?
Yeah, how do you know which it is? The context. So here, because I already gave you the length, I must be asking you for the time. You see, if I said how long is the pendulum for it to swing in 2 seconds, then because I've given you the time, then I must be asking for the length. Hang on, I can't quite hear her. Say again.
Like, does it mean to be sort of like this length?
Yeah, but how long could mean both. How long could mean what is the time or what is the length. It has two meanings. I'm sure this is not the same in other languages, right? I mean, in Korean you don't have the same question for two questions. Yeah. So it's a problem. The reason, well, maybe, I don't know, you can tell me if it's the same in your language. Think about your language. If I said in English, the length of time, or the length of the table, I'm using the same word for both, the length of time and the length of the table. Think about in your language, translating that sentence. Are you using the same word? Do you also say in your language, the length of the table and the length of time? Is it the same word or is it a different word?
Same word.
Okay, so when we say how long, it's like what is the length of time, or I could mean what is the length of the table. How long? Is it the same in Korean, the same word? It's different. So the length of time and the length of the table, two different words. And in Chinese? Same word? And your native language? And so it's the same. And yours is? So is it the same word? So the length of time?
Most of the time they change the tense.
The tense is changed. So it's not exactly the same word. So you can tell the difference. Yeah, okay.
Yeah, like even like it's the same word, but when you ask the question, you kind of it's a different word.
You can tell. So
they usually do change the word.
Yeah. Yeah, okay. So it's never like this where, yeah. So for me in English, I can tell because of what information I gave you. You know. Yeah. What's your native language? Malaysian. So is it the same or a different word?
Quite the same actually.
But is it like an actual different word you'd write down? The length of time and the length of the table?
No, you just go like how long and what length or something like that.
Okay. Right.
Wrap up again.
You're not certain?
No.
Okay, that's alright. Now, congrats. That's the end of mechanics. This lesson was quite short, but what's very important with this lesson is the proof I gave you. Not that you need the proof for the exam. You don't need the proof for the exam. You need it for your lab report next semester. Okay? So I think what would be good is if you I think I gave you one question, was it, or two questions? How many did I give you in the book there for the pendulum? One or two questions? Two. Yeah. Can I see the two? It was originally one question, but then I thought one is too generous, so I made it two. Only two questions. By the way, when they're like this, they're obviously section B style. Like, you see this one here? That would be a section A question, and this would be like a section B question. So obviously in section A it's very, very easy. So this is more like section B. Can you try these for a few minutes, and then we'll have a tutorial? Yeah.
Can I see the proof again?
Oh yeah, before I close it, good. So let me just, I'll just leave it on the screen, will I? You let me know when you're finished with it. That choice is so I can go from there to there.
Also, yeah, two formulas in this.
No, sorry. This is my result. This is what I want at the end of the day. This is it's a proof of this formula. Do you get what I'm saying? So what I'm trying to do, I'm trying to find a T formula for the pendulum. I want to figure out a formula for the time. So I have succeeded. Most years I succeed to find the formula. Got it? Now guys, if you're interested, I'll just do an extra little piece here. Just in case you're interested, this formula is not exact. I mean, it's really, really close, but it's not 100% exact. Maybe it's like 99% right. And the reason for that is because of this step here. Because it's only roughly true. In fact, this answer is a little bit too big. It's a little bit too big, right? Because the path is curved where it should be straight. So you could think about it like this. You could say, well, if I want to fix it, I should subtract some small number. So you could then say, over here, minus mgx, minus mg x over L minus some small number equals ma. So the m's cancel. So the a you get is minus g over Lx minus plus ge. Now you see the problem is we don't want this guy here because we're trying to get this formula. You know, so this is why we don't consider the curve, because we don't want this here. Now this is very, very small, but this isn't too small. This is like 9.81, so it's not like it's completely zero here. It's still a sizable number. So when we discard it, the acceleration we have, if this is the true one, is the one I'm using bigger or smaller? Smaller, isn't it? So the A is smaller. So if the A is smaller, then that should mean the T that I calculate is smaller. Yeah. So this answer here is a little bit, just a tiny bit too small. There should be like an extra part of the formula that we stick on at the end. Okay. So this missing piece in physics, whenever we have a piece missing from the formula, we call the missing piece the error correction. It's like a tiny little amount that you didn't consider. Okay. In fact, we'll talk more about this as well in semester 2. Right. Can I close this now? Yeah. All right.